Welcome back, everybody. This is the Pipe Dreams Ramda Deep Dive Season 2. We're going to continue with Flatten. I do want to apologize for the audio from the last two videos. I decided to try to go to the park, and the noise cancellation just doesn't work for some reason that well with my AirPods. Uh, but anyway, um, I'm back inside now, and we will continue with Flatten. And, I was thinking about Randa as a whole, and a lot of what Randa does is reorders built-in JavaScript functions and array methods and string methods and things like that. So they can be composable, and they can they have the data last and they're curried. And I think that's really the first thing that you want to focus on is just using Ramda's versions of things like map and filter and flatten here that we're going to talk about. And then there's other functions in Ramda that are convenient. They do things that are common and can be frustrating. And this one's kind of in between because JavaScript, I don't believe, has an array method called flatten. They have one called flat, and we can look at that here in the docs. And it's pretty straightforward if you have a list. Maybe I zoom in. If you have a list like this, 0, 1, 2, and then a list nested with 3 and 4, and you call flat on it, and it gives you, a flattened array. But if you have something like this with nested arrays, it becomes a little bit more inconvenient. Let's run that. Let's see. I did not do what I thought I was doing. Let's copy this. There we go. And we don't need the console part. I run that, and did it do anything? 0, 1, 2. Yeah. So it unwrapped one level, but we still have these nested arrays. So you can do you can put an argument in here, and then now we've nested or unnested two levels deep. And then we can do this, and that's fine. I mean, it's okay. You have to know how many levels deep something is nested, or you have to checking to see if the item in the array is an object or is an array, because in JavaScript arrays are objects. However, there are methods like array is array. I'm not going to try to code that because it gets really hairy and complicated. Um, if you needed to do that, I think the best thing to do, obviously, is just Google a recursive flatten um, function or something like that. Uh, because we might not always know how many levels of flattening we need to do. So flatten, if I go back to Ramda, it returns a new list by pulling out every item out of it and all its subarrays, right? So if I use Ramda's r dot flat n, I don't need, yeah, I just need the one argument here, I believe. If I run that, there we go. Now we've got our completely unnested array, one array with no nested items inside of it. So that's super handy, I think. Um, you may have, especially when you have something like map, right? We're using map, filter, reduce a lot because those three methods you can do, 80-90% of what you want to do with lists. Um, but let's say we had a duplicate function that took an X and just doubled it, like, gave you two of each item in an array, like a pair. So, give it one, it gives you back one and one in an array. And then let's pipe it. Let's do a pipe here. And in the original series, I know we Chris used pipe. He also talked about compose a lot, and uh, now there was compose R and pipe R. No, compose P and pipe P. Those have been since replaced with compose with and pipe with. They do the same thing, but they're more general. But anyway, if you haven't looked into pipe, first I would go back and watch Chris's video about compose and pipe. But we're essentially just listing several functions inside pipe and stitching them together to create one new function. So I think of it as, and I think of Ramda in general as being a bunch of ingredients in a kitchen, and you just kind of grab each thing, and like pipe might be like a bowl, like a mixing bowl. You just kind of throw in all the functions into the pipe, and then once you add your data, apply the function the pipe gives you back to your data, you're essentially just running it through all the ingredients. That's one metaphor. Another one might be like a conveyor belt in a factory, where it starts on one end and it goes through and it's transformed by all these functions that are included in pipe, and then it gives you a result back at the end. Of course, where that metaphor breaks down is if you sent a product through a conveyor belt, it would be mutating that product. But in our case, it's just making a copy. It's taking the original value, making a copy, and transforming that copy because we're doing immutable things. But anyway, if we map through, I'm going to call this X's, and actually, I'm just going to go back to a simple 1, 2, 3, 4, 5 array. And let's say we map that with duplicate. Um, get rid of this log. Let's see. There's no data. So it is interesting, though, that it's this function anonymous. Maybe that has something to do with the pipe. Let me log out the pipe for a second, or comment out the pipe. Yeah, yeah, it has something to do with that. It's interesting. I'm not sure what that anonymous means. Let me know if anybody has seen that type of output. But yeah, function one. So we don't need the pipe actually anyway because we're just running this one function. Yeah, and so here, we get duplicates of everything. So we pass in 1, 2, 3, 4, 5. We get 1, 1, 2, 2, 3, 4, 4, 5, 5. But what if we wanted that on a list? So here, let's bring our pipe back in. That's the data at the end of the pipe. And we're going to do r.flatten. And there we go. Yeah, it threw me off for a second because it's on two lines. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. So it can be very helpful. When you get into working with, I dare say the word monad, I'm starting to understand category theory a little bit, but not well enough to explain it yet. not explain it well, at least. Uh, but that's the idea of flattening, and we looked at chain before, and chain is often called flat map. Where does it say? Yeah, also known as flat map in some libraries. And flat map maps something and then it flattens that result. So often you'll use flattening when you are already returning something like a monad, like a list. Map is going to already return a list, but then you're doing something inside with the mapping function that returns a list as well, and then you end up with list of lists, and that may be what you want. But as far as chaining things together, sometimes you want to flatten it. So slightly different uses of flat map, or called chain here, and just flatten. But flatten is really good. I would just consider it a recursive flat. Now the question is, what if I want to control how many layers of flattening happens? Let's go back to flatten, putting them in a new array depth first. So that is interesting because I don't see, unless it's called something else, I don't see a way just to use flat. Now, of course, we could make our own, because this flatten is probably a little bit hairy. Let's go look at the code. Using a function called make flat, an internal function. I'm gonna go look at that just briefly. So maybe it's in source. It is not. Ah, I just saw it. An internal make flat. Yeah, so make flat returns a function called flat with two T's, takes a list, and then again we're using this while loop. Yeah, and then you have to check if it's an array or if it's an array like. Wow, we got while statements with an if statement with the while inside, nested inside the if statement. That's not something I want to see when I'm coding. Um, so that didn't really answer my question though. And I also see also unnest. So maybe flatten and unnest, maybe does what I want to do. But if we want to just re-implement flat, where we could choose the level of flattening, um, we could say flat equals take x, because that'll be, or we could say n for the number of flattening, the level of nesting to unnest, and then return a function that takes the list, our x's, and then just do it the built-in way where we take the x's and call the flat method, pass the n to it, comment this out, and then let's say, oh, uh, that was nested, and then the 4 and 5 are nested inside that. So we got 3 levels of nesting, and then we could say flats um, 2. So we want to leave 1 level of nesting, and then so the way I created the function, it's not auto curried, it's just curried. We have to call it with two sets of parentheses. That flattened it. Maybe I need one, maybe two levels. Yeah, I think that's it. Yeah, there we go. So we could control. What if we did like four? What would that do? Would that just flatten it? Yeah. So you can always go with like a big number here, like in CSS with Z indexes and what minus 9,000, that's the sweet spot. Um, but that's not what you want to do because you're just guessing it. So flatten would be better for something like this. But I think we've looked at curry and uncurry. Actually, I've looked at it watching the original series. Uh, but we could do that with this. We could say const, and I'll just do like well, I'll just say uncurry, uncurried flat equals r dot uncurry. That's weird. Well, IntelliSense tells me there is no uncurry in, but I'm sure there's a uncurry. I can uncurry my flat function, and then we could call it down here, like I guess dare say normally, where we're passing both arguments at one time. So, or more technically, a binary function, right? Or binary arity, a function that takes two arguments at one time. That's what I'm trying to say. And that gave me a syntax error. So it says uncurry, not a function. Really? No, it's not. That's interesting. So uncurry returns a function of arity n from a manually curried function. Okay, so you do have to pass it two arguments. So the first one is how many arguments it should take. I wonder why that is. Maybe it has something to do with the fact that functions could take as many arguments as you create them to take. And so it needs to have some way of knowing um, how many arguments you want. Returns a function of arity n from a manually curried function. Note that the return function is actually a Ramda style curried function, which can accept one or more arguments in each function call. That's interesting too. So it's like it's uncurried, but it doesn't have to be. Let's go down here, run this. Yeah, so that did what we want. Flattened two levels. Oh, I see. Uncurried flat. Let's see here. I'm confused because my flat function takes one argument and it flattens it by that number of levels. And then I'm just uncurrying that function flat, specifying that the arguments should take two arguments, and I flatten it. And here I passed in four, but I want to really just unflatten it one. And that gives me back what I wanted. But the key is that I can call it like this now. And then I guess what they're saying is that even though I've uncurried it, it can still be curried. Yeah. So it looks like when you use uncurry in, it gives you the possibility of not currying it. It basically turns it into like Ramda style currying, where currying is an option, but not required. You can do both. So that's actually pretty cool. So that means you can, on the fly, make a function that's curried and then be able to use it either curried or uncurried, which is pretty useful. I mean, half the time it might be easier just to write a function this simple than look up what function to use in Ramda, in a pinch. Yeah, I like that a lot. So let's go back here to flatten. Type signature is a breeze. It takes a list of A's and returns a list of B's. So I believe in category theory, that would be called an endofunctor, which would be something that can be mapped, but maps from one category to the same category. And if I'm correct, that category would be a list. Um, because it's not types, because you could have A is a number, and then you could map that list using toString or the string constructor, and then return strings. Those would be two different types, but I still believe that would be an endofunctor. But again, I'm talking about category theory, and I'm just learning it, and it's very difficult to understand and remember the difference between functors and endofunctors and monads and monoids and all those crazy things. Um, and then if I expand the parameters, yeah, the array to consider, and it gives you the flattened list. So yeah, flatten, super simple way to recursively flatten something. Let's look at unnest too. And now we're getting into a type signature that is a bit like getting into the world of these, I don't know what to call them, but here we see that there is a type class C. So C has to be something that can be chained, and lists can be chained together. We've seen that using flat map. Um, so let's see. So if C is something that can be chained, which I believe that's a monad. I don't know. I don't even want anybody to correct me because I'm just too far off away from that. But let's bring it back home to this Ramda and JavaScript for mere mortals like myself. But if C is something that can be chained, we take a C and apply it to, well, first we apply C to A. Or is that the arguments, the two arguments, like C and A? But I believe we're reading that as C is applied to the result of C applied to A, and then it returns two things. That is a tricky one for me. Let's expand the parameters and look. Oh wow, it doesn't give us a lot. But so it's saying that it takes a list and returns anything, okay. That doesn't help me so much. So this does shorthand for chain R dot identity, which removes one level of nesting from any chain. There we go. And that's what I was talking about before. Oh, yeah. So this would be like flat, right? And it says C also flatten, which we just looked at, and that flattens recursively. We looked at chain. I'm going to go back real quick. Yeah, chain M, and I'm sure M is for monad. Yeah, and here we've got the duplicate function that returns, so if we pass 1, 2, 3, it gives us back 1, 1, 2, 2, 3, 3, and then we're flattening it. So we map using the duplicate function, and then we get a new array of arrays, and then we flatten those arrays. Unnest, even though we have this complicated type signature, I believe it is just going to flatten one level deep. So let's try that. So we've got our x's with one level, a second level, and a third level. But I guess you would kind of consider that at like zero level, one level, two level. If you're thinking about how you would specify the level of nesting you want to unnest. So let's just do it simple and just say art unnest. And looking down here, I don't think we need any arguments except for the data. And so if this is right, if I'm right, we should get back one, two, three, and then an array with four and five. One, two, three, an array of four and five. Yeah. Yeah. So just one level of nesting. I I question why they didn't call it flat and flatten, because this is, well, I guess because the built-in array method of flat allows you to specify the level of flattening with a number, and this just is always one. So my next question is, how do you do in between? What if I want two levels of unnesting? I don't want to recursively flatten it. I want to flatten it more than one. You could do this and ask the data here last and just do it twice. Because I mean, you either want it to flatten one level or you want it to flatten all levels without necessarily knowing what the list is going to be. But in between, you're going to have to decide manually how to do it. And I mean, in most cases, you're not going to flatten 60 times. You're not going to get data like that. Yeah, let's flatten it. Let's do one more level here. Yeah. Yeah, so I guess that's how you would do it if you wanted control over how much flattening you wanted. And then you could do things conditionally, like if something flatten it twice, if something else flatten it three times. Um, yeah, yeah, that's nice. So I guess that natively all you've got is flat, and you have to build your own recursively flat. This Ramda gives you recursively flatten, it gives you unnest for a single flat, and then you can decide how many times to flatten it. Of course, this, I say I'm not worried about performance, but doing it like this, you would be iterating through the list twice to flatten it each time. And I mean, you could have a really big list. So I think there's some way to handle that. Well, flat map would do that. I mean, flat map will map and then flatten all in one go without iterating through the list twice. So I think there's probably some way to specify or some way to unnest twice without iterating twice, or three times without iterating three times. But I don't know what that is, and hopefully I'll come across it. But if anybody does know the function, I'd like to take just a quick peek at it. Um, so let me know in the comments if you know anything about that. Otherwise, in the next video, we're going to be looking at flip, and that's cool because this is a list function, but flip is just like there's no built-in flip in JavaScript. So this is one of those cool functions that Randa provides that they just made up. It's not rewriting some part of the built-in JavaScript language. So anyway, thanks for spending your time with me, and tell a friend, and I'll see you in the next video.